In this lecture, we're going to be talking about technical models. So in the last lecture, we talked about business models and kind of walked through what a business analyst would utilize in that case. Here, we're going to talk about technical models. These models may be something that you utilize a little bit less as a business analyst, because this is generally more for IT business analysts or designers, developers, that type of thing. But it's a great thing to understand what they are. One, in case you want to go into the IT side of business analysis. But two is just to understand what that model is showing. So if somebody shows it to you, you have an understanding of what it is and basically the pros and cons to what it's showing. So the first one we're going to talk about is the system context diagram. This is a very high-level diagram that's showing the system, and it's showing what people or systems are interacting with that system and how. So here in the center, you see the main system, the hospital invoice system. On the outside, you have three actors, and in this case, they're people, and they're groups of people. So you have the patient, you have the billing clerk, and you have doctors. And so what this is showing is the interactions of data between the hospital invoice system and those particular people. So starting off with the patient receives invoices. That's why you have the arrow or the data flow going out, and the patient makes payments, and that's why you have payments going into the invoice system. Moving over to the upper right-hand corner, the hospital invoice system sends the invoice details to the billing clerk, and the billing clerk goes in and maintains that patient data. They go in and update the patient data within that hospital invoice system. And then finally, the doctors are recording treatment. So at a very high level, you have an understanding of what actors are going to be interacting with the system and what data is going to be flowing in different directions. And it can help you drive out requirements. The next thing we're going to look at is a little bit deeper, and that's a data flow diagram. So the other one we were looking at a really high level. Now we're going to drive in just a little bit more, and this is a different example. So the circles are processes, the rectangles are external entities, two lines together is a database, and then all the different squiggly lines with the arrows are your data flow. So we're not going to walk through all of these, but ultimately if we start with the customer, they put in a PIN number into this ATM machine, and it goes into the process of validate PIN. So the validate PIN is going and working with the customer bank records to determine if that PIN is authorized. So we have a PIN authorization data flow there, and then we have a PIN reject notice, which goes to the security department and the customer. And we work through, and we have a process withdrawal, and we have the transaction. So you can just see all the different ways that the data can flow through the two external entities, the security department and the customer. We have one database, which is the customer bank records, which is where we're validating information and sending withdrawal information to and updating records there. And we have the two processes of the validate PIN and process withdrawal. So you can just kind of see in the data flow diagram, it helps to show where the data is flowing, how it's working, and this will help you define the requirements. So now you need to understand, okay, where is the customer putting the PIN into, and you can start to drive into the different levels of requirements and validate that you have a good understanding of what data is flowing where. Next is the CRUD matrix, and I have this on the next two slides, and the CRUD rate matrix is all about create, read, update, delete. So this is looking at it from a kind of a database perspective, and it's talking about, in this particular one, the roles are across the top, and then you have your specific information across the left-hand column. And so what this is it's talking about the doctor, nurse, billing clerk, and billing manager. Can they create, read, update, or delete the information? So looking at the patient history, the doctor can create patient history, the doctor can read patient history, and the doctor can update patient history. That makes sense, right? The nurse, they can read and update patient history. So the nurse cannot add anything to patient history, only the doctor can. The billing clerk and the billing manager, they can only read the patient history. So they can just see it, and that's for obvious billing reasons, right? They don't need to be able to create or update that information that's left. Update is both the nurse and the doctor, and create is just the doctor. So this helps to break down those pieces of information and all the different kind of levels there. and you determine who needs what access for certain information, and this helps drive out some of your security requirements as you work through. A lot of this is done in design, but understanding, at least at a high level, your requirements have to be able to dictate who needs access to what at certain points. The next CRUD matrix is going through, and it's just talking about the processes rather than the information. So you have the entities across the top, which are basically like the tables or the actors, and the processes along the left-hand side. So for the process patient intake, that particular process needs to be able to create, read, and update the patient record, which makes sense, right? I mean, you have to be able to create, read, and update a patient record. You got to create it if they don't exist when you're intaking that patient. You need to be able to read. I mean, that's obvious, to be able to look them up, and you need to be able to update in case that information is no longer available. You don't have the option to delete, because when you're processing a patient, you should never have to delete any information. And so you're able to look through all those different processes and see the level of security and the level of availability that data need to have there. It's very important from a security standpoint that you don't have processes that need access to certain things. So if you look down at the invoice patient process for the patient history entity, there's nothing there. It doesn't need to read, it doesn't need to update, it doesn't need to create, it doesn't need to delete any information from the patient history. That is not relevant from the invoicing perspective. So that's the CRUD matrix. This is definitely useful, and this would be one as a business analyst that you may actually utilize even outside of being technical potentially. The state diagram goes through and it helps you to understand the states of certain records and what it means. So this particular one is working through the process and the process of intaking a patient and what their standing is based on their level of payments. So the first thing you're doing is you're starting in the black dot on the left-hand side, and that you're registering the patient. So then you're going into they're in good standing, right? You first register them, they're in good standing. They haven't done anything wrong at that point. If you look to the right then, you can say, okay, are any of their bills more than 60 days outstanding? If so, then they should be changed to overdue. If they would pay their bill, then they would be back to good standing. Off to the right of overdue, determine if they're 90 days or more than 90 days outstanding, then they would go to in collections. But guess what? If they pay their bill, they're back in good standing. So you can kind of follow all the different processes and all the different transitions to the different states based on the different criteria and things that are happening throughout those. So the state diagram is definitely really nice, and you will likely use this as a business analyst. This is a more technical model, but this is one that I've used a ton, especially as you move through, sales organizations. You're talking opportunities and opportunity statuses, or accounts and account statuses, and you're just kind of walking through the different statuses. And the state diagram does a good job to show you how a particular entity or group or person works through and ends up in different statuses and how they get out of those statuses. The next modeling technique we're going to talk about is the entity relationship diagram, the ERD. As a business analyst, you'll likely never do this unless you're very, very technical. This is ultimately designing the way the database will look. And so this is a database design type of concept. So you're understanding what the different entities or tables are and the attributes to those particular tables, and then how it relates to other tables. And I wanted to show you this. You'll likely never create it, but at least show you this so you know how to read it and how to understand it. So you have the entity, which I have off the left, the key. So you have the entity. The first one or couple attributes are considered the primary key. Ultimately, that means those are going to be uniquely identifying that particular record. And so think of an entity as an Excel spreadsheet, and the entity is owning the full thing. So that is the entity. And then the records within it are the different rows within that Excel spreadsheet. And so you have attributes potentially across the top. So for student, you have the student ID, you have the student's social security number, and the student full name as columns across the top of Excel. In the left-hand column now, or in the rows, you have all the different records. So you have your student ID of 1, social security number of whatever, full name as Bob Smith. Student ID of 2, social security number of whatever, full name as Betty Davis. And those are the different records within that. So you can see with the student, those attributes are what's being stored within that table for that particular entity. Now, looking at relationships. So this is where it's going to get a little confusing, so I'm going to keep it at a high level. But there's ways that this entity relationship diagram is tying the data between the different tables. It's called a relational database. And so when you look at this, you can make some determinations from that. So let's look at the student and the student class. And we see that on the student side, we've got 2 lines. And on the student class, we've got this crow's feet looking thing with a circle. So if we look at the key, that means that the relationship is a 1-to-0 relationship. 1-to-0 or many. And so what that means is the student can have 1-to-0 or many student class records. So ultimately that student can enroll in 1, 0, or many classes. And you see the opposite relationship on the class side. So that student class is holding the data between the student and the class. So that student can enroll in that class and a record gets entered into that student class specific entity or table to be able to house that. And that's what the entity relationship diagram is all about. Other things we can depict from this particular entity relationship diagram. So we know one student can enroll in 1, 0, or many classes. One course can have 0, 1, or many classes. One course can have 0, 1, or many instructor courses. And the instructor, there has to be at least 1 or many instructors in an instructor course. So that's saying that an instructor has to be present in every course, but that course could have many instructors. And so you're able to kind of break this down. And like I said, this is getting technical, so I apologize if I lost you, but just understand that this can show the relationships and you can make some determinations based on the particular model. So I hope that helps to give you some information on the technical aspects and the technical models that are available and that are most common, and that when you see them, you definitely won't be confused and you can maybe pull some information from them.